Well, we are in our last unit with learning how to solve our systems of equations. And really, systems of equations means we're given two equations and we're looking for that solution that might work for both of them. So again, we are continuing to work with our slope-intercept form of y equals mx plus b. Remember how easy that was to graph. So we're going to keep using that equation. So looking at the two equations that they gave us here, I know my slope is 3 over 1 for that first one, and the y-intercept's -2. With the second equation, again, -2 over 1 for the slope, but my intercept is 3. Remember how we graph it, and that is always starting with your y-intercept first. So I'm going to look at that first equation. Y-intercept is at -2, and now my slope is +3 over 1. So up 3 over 1. Up 3 over 1. So that's going to be my line. Go ahead and connect those. And when I do, oops, I got to draw it straight. You can see that I have my graph. There's my line of my linear equation. And now I do the same thing for the second one. That one says that my slope is +3. My intercept, is +3. And my slope is a -2 over 1, which means I'm going to be going down 2 over 1, down 2 over 1. And again, going ahead and connecting those. And I've got the graph for that linear equation. And you should see they actually intersect at one point. This right here. Well, what point is that? That is 1, 1, which means that right there is my solution. That is the one and only point that works for both those equations. So when I get down to B, it's just basically saying, how can you tell that this point would not work in my equation? And I basically said, well, plug in your x and your y. And when you do, you can see -1 does not equal 4. It's a false solution, so it is not a solution. When I go over to C, it's telling me, well, what about that point in the other line? How do you know it is? Again, plugging in that x and y and coming up with -1 is equal to -1. Well, that's a true statement, which means it is a solution. And then right there, going ahead and saying, explain how the graph can tell you if it is a solution or not. Well, look at the point and then look at the line. If it's on the line, it is a solution. If it's not on the line, it's not. And of course, if I ever asked you to check your work, which I've done many times, to check the work, take that point that you have and plug it in to both the equations, changing your x and y to the point. If you get a true statement on both, then you know that is a solution to that system of equations. Let's go ahead and look at that next page. And again, solving those systems, that y equals mx plus b. So I've already kind of mapped it out for you, told you what the slopes are by just looking at the equation. And now we're going to go ahead and graph them. So let's go ahead and graph that first equation right here. Again, starting with your y-intercept at 4. And my slope is -1. So I have to go down 1 over 1, down 1 over 1, and that's going to give me my other points on that line. So when I go ahead and connect those dots, you can see so far the graph of that linear equation. Now let's go ahead and look at that second equation. We're going to graph that. Notice there is no y-intercept, which means it's a proportion. It crosses at the origin. And now use that slope up 3 over 1, up 3 over 1, and keep going, and you will find that, whoops, I didn't do that one right. I gotta go back. Up 3 over 1, up 3 over 1, and now connect those points, and now you've got that linear graph. Where they cross is my solution. So my solution is 1, 3. Now let's do the next one. I can map out, I can see what my slope is, I can see what that y-intercept is on both of them. So let's go ahead and graph that first equation, and I can see that my y-intercept is -2, and my slope is positive 2 over 1. So up 2 over 1, up 2 over 1, connect those lines. There we go. And there's the graph for that linear equation. Now let's go ahead and do the next one. We're going to go ahead and start with that y-intercept, which is positive 4. The slope is also 2 over 1. So that means up 2 over 1. Oh, I'm going to go off the graph if I go up 2 and over 1. So I could go backwards from the y-intercept. Down 2 over 1 if I want one more point. Connect those lines, and wait a minute. They don't intersect at all. In fact, they're parallel to each other. If graphs are parallel to each other, because the slopes are the same, but your y-intercepts are different, well then that means there is no solution. They will never cross. There is no point that will work on both those equations. If we look at this third example, again, we write out our slope and our y-intercept. In fact, here, I need to use that distributive property first to really see what I'm talking about. And now let's go ahead and graph that first one right here, our y-intercept of -3. And then slope of 3, 3 over 1. 1, 2, 3 over 1, 1, 2, 3 over 1. And now let's go ahead and graph. There is the graph for that linear equation. And now we can go to that second equation. Again, -3, and slope is 3. Up 3 over 1, up 3 over 1. Oh, wait a minute. That is the exact same line. They actually overlap. They have the same slope with the same y-intercept, which means there is infinitely many solutions. Infinitely many. So again, if they overlap with the same slope, same y-intercept, many solutions. If they're parallel, same slope, different y-intercepts, no solution. And then the last thing I want us to look at is how can I make a system of equations with a word problem? Well, that's when we have to be careful and really kind of look at what it's saying. If it's a system of equation, there's going to be two different statements being made. So I kind of highlighted them for you with Keisha and her friends at this football game. First, they're talking about how much things cost, and then they're talking about how many things they buy. Those are the two separate equations we're going to look at. So if I look at what's in green here, and I can see those friends are going to buy a total of 8 items, I'm not sure how many hot dogs they're going to get. So I'm just going to call that X. I can call it whatever I want. If I want that to be the drinks, I could. I'm just going to make my hot dogs X. And then the number of drinks, I don't know how many there are, that's going to be my Y. So I've got my two different variables. How many things did they end up buying? A total of 8 items. So I have my first equation. x plus y equals 8. But you know when we're going to graph, which we're going to, I need to have it in my y equals mx plus b form. So isolate the variable y in this equation to get it in that form. Now let's go ahead and look at the blue. The other thing they talked about is the cost of these items. Well, $2 is a hot dog. We made our hot dogs X, didn't we? So that's going to be 2 times X, $2 for every hot dog. $1 for a drink. We made our drinks Y. So that's just going to be 1Y, or just Y. And now, how much did it all come up to be? $11. Now we're going to go ahead and actually solve and isolate that variable for y. So if I subtract 2x on both sides, that should help me get that form y equals negative 2x plus 11. Now that is in my y equals mx plus b form. There's my second equation to help me do my graphing. So here's my first equation. We just solved for that second equation. And now we can actually graph to find the solution for our answers for x and y. So again, remember, look at your y-intercepts, and we want to look at our slopes. So let's start with that first equation, going to the y-intercept of 8. And then we have a slope of negative 1, which means, again, remember, down 1 over 1, down 1 over 1. So you can keep going and get as many points as you want, so you have a good idea of what it looks like. And then, of course, graphing and getting that line on there. So there's my first one. Now let's look at our second. The y-intercept is 11. And my slope is negative 2. So remember, that's down 2 over 1, down 2 over 1, down 2 over 1. And again, as many as you need to get a good sense of what that line is going to look like. And when we are all finished, we can see there is one solution. And that solution is when x is 3 and y is 5. So my solution is 3, 5. 3 hot dogs, 5 drinks. If I ask you to check your work, you're going to take that solution you just got and you're going to change that x and y into both the equations that we got up here on the top. Those two equations, put it in. If you get a true statement on both of them, then you know that is the solution. And again, we made our hot dogs X and our drinks Y. So that's how it kind of looks when I have it in a word problem. Make sure you write down any questions and bring them to class because we will be working on this together.